If I had to give you
Yes.
$100 to put on something in 20 years that's going to be profoundly, it's going to change us in a
Yes.
way that is something that we're not really prepared to understand or deal with. What do you think that's going to be?
I think it's going to be predictive genetics. That we're going to have right now, it's like you go to your doctor when you're sick. This could have been some genetic disorder that you had from the moment you were conceived.
And it was ticking.
And you showed up 50 years later when that's been manifest. So it's going to be very different. You're taking your kid home from the hospital, your newborn. And the doctor says, hey, congratulations, this is really great. But just FYI, your kid has a 50% greater than average chance of getting early onset Alzheimer's 50 years from now. And your kid has a really great chance of being phenomenal at abstract math. Like, how are we going to think about that? How are we going to think about what it means to be human when we have all of that information? And there are things now that we call fate. And it's just a different model. And so I think that, and once we have that, that's going to change a lot of things. It's going to fundamentally transform our healthcare. What we call healthcare now is really sick care. You show up with a symptom. And this is going to be predictive, and it's going to change the way we make babies, because people are going to have real choices about which embryos to implant, and we're going to have a lot of information about a lot of really intimate stuff.
So you feel like genetic manipulation and genetic engineering, genetic understanding, genetic knowledge, and then applied genetic medicine.
Yes.
Those are going to be the big changes in the next 20 years, even more so than technology.
Well, it's interconnected, because it's like a super convergence of these technologies. So the genetics revolution is the artificial intelligence revolution, in the sense that the complexity of genetics is so great. It's way beyond what our brains on their own could process. And so really, all these technologies are touching each other. And so the biological models are now influencing the AI. So, for example, we are coming to the limits of silicon storage, but DNA has unlimited storage capacity. So it's as I've said before, the boundaries between biology and AI, or genetics and AI, is going to be very blurry.
Yeah, that is an interesting concept, right? The idea of storing information in DNA,
right.
And that has been discussed.
Yeah, well, DNA is the greatest information storage mechanism ever imagined.
But the question is, what happens when you do store things in there, and how does that information interact with all the rest of the stuff that's in your body already?
Well, I mean, if you can do it in your body, it doesn't have to be in your body. But just think of your DNA has 4 billion years of history, and it's done a great job of recording it. It's incredible.
Yeah.
Like I have old 8-track tapes. They haven't lasted.
That is a squirrely concept, that you have all that data inside your head. I mean, that's also when people when they try to understand instincts that people have, that these are some sort of genetically encoded memories, or some understanding of things that are dangerous, and that they're in there because this is how we've learned over the years without actually having to experience these things personally.
No, so it's baked in. Our genetics are baked into us. And so